In this video, we are going to understand how LLMs understand the meaning behind words which we give as inputs. It understands it using embeddings. Now, what are embeddings? Embeddings are basically the numerical representation of data. That data can be a text, image, audio, any kind of data input, which we give to multimodal large language models. So why we map a particular data point or input text to numbers. The LLMs are working on a hardware, which is a computer, and computer understand only zeros and ones, which in turn makes them understand only numbers. They don't understand any kind of language which we talk, whether it's English, Spanish, anything. They only understand the language of zeros and ones, which in turn helps them to understand numbers. So therefore, to make them understand our language, we need to convert our language into numbers. And how can we do that? For that, we convert every word into the numerical representation of them. So this is embeddings. Like, let's give an example of king. King can be represented by a couple of numbers, as you can see in the screen. So there are multiple numbers used to represent a same word together. And these numbers are together put inside a vector. A vector is basically an one-dimensional array. Array is basically a data structure which stores similar data types. Here it is numbers. So all these numbers together represent king, which is a word. So you might ask, how can all these numbers together represent a word? So I want to explain this using a very simple example. Like, let's say in the universe, there are only two words, king and queen. There are no other words present in the entire vocabulary of the universe. How will you represent them? What is the number of dimensions you need to represent them? For this, you only need one dimension. And you can place both these numbers in, let's say, +1 and -1. So +1 represents king and -1 represents queen. They are a distance apart. Now let's bring another word, prince. Where will you place this? Will you place it at 0? Will you place it at -1? Will you place it at +1 or any other point? Where will you place? You will definitely place it near king because king is a male and a prince is also a male. So it makes more sense to put prince more closer to king and less closer to queen, right? This is the exact principle on which embeddings work on. They basically represent all these words into n-dimensional space. So here it is 1D space, therefore we have only one number to represent a particular word. But for n-dimensional space, let's say 64-dimensional space, we will have 64 numbers to represent a particular word. So when we place that word in that particular location in the embedding or the vector space, what happens is, if we take another word, we can correlate whether that particular word is closer to the meaning of the word which is already present in a particular location. If it is close, we'll place the new word closer to the existing word. This ensures they are more aligned. So words with similar meaning are placed closer to each other, and words with meanings much different are placed away from each other. This is the basic concept behind embeddings. And this is how we represent each and every word in n-dimensional vector space. I hope this helps you understand what is a vector space. Vector space is basically n-dimensional numbers which is used to represent a particular word. Each piece of data after conversion is placed in a high dimensional space, which is the dimension is the number of numbers used to represent that particular word or text or token. The most precise word will be token. So this is how we cluster similar words together. And this helps us in understanding languages better. Now, distances represent similarity. There are different ways to calculate distances. Closer distances mean similar meaning, and farther distances mean different meaning. This is the foundation behind search engines, recommendation systems, which we generally use in Amazon or any other e-commerce websites, the RAG pipelines, and the memory systems, like anything you ask from large language model. How does it understand the meaning behind the question you asked? using the same principles of embeddings. Okay, so there are specialized models which generate these embeddings. Some examples are like we have OpenAI's embedded models. We have sentence transformers, which are very famous. We have BGE models, E5 models. So higher dimensional embeddings allow richer representation, but in turn, they also consume more compute and storage. So if the meaning of two words are similar, their embeddings will also be very similar. And you know where these embeddings are stored? So these embeddings are not stored in traditional databases like SQL and NoSQL, etc. They are stored in special databases called vector databases. Some examples of companies which provide these kind of databases are Pinecone, Phase. Their job is to find the most similar vectors among millions and billions of embeddings. So how embeddings are used in RAG applications. So this is very important for AI engineers. So when you upload a document, first it is passed through an embedding model, and the embeddings which are created for those documents are stored in a vector database. So when then a user queries a particular question, so when a user asks a query, that query is first converted into an embedding using an embedding model. Using the same embedding model we used to convert that document into embeddings. And then the query embedding of the user is used for similarity search to find all the relevant chunks of the document which are uploaded. And then the large language model generates answer using all those embeddings as context. So this is how ChatGPT like applications can answer questions from private company documents. So a very common misconception is that embedding is a kind of memory. No, they are not. They are not databases. They do not act like databases. They store numerical representation of a text. So they store a mathematical representation of meaning. So the actual content still lives in documents. Embedding simply helps us find the relevant information quickly. And also remember this, that embeddings are used beyond text. Like embeddings are used to represent text, images, videos, audios. This allows for cross-modal AI systems. So simply put, tokens are basically how models read language, and embeddings are how models understand the meaning behind those languages. So here are the key takeaways from this video. First, embeddings convert data into vectors. Similar meanings produce similar vectors. Distance between vectors are measured using similarity search like cosine similarity, Euclidean distance, etc. Cosine similarity is the most common similarity search method. Embeddings powers semantic search, RAG applications, and recommendations, etc. Vector databases helps us in storing and retrieving embeddings efficiently. Embeddings are one of the most important building blocks of AI-powered applications. Now, how will we measure whether this word is similar to that word? For this, mathematically, we use cosine similarity.